Good Monday morning to you. This is a little presentation I put together that's not all that long, but it's about a couple of vehicles I managed to use pinouts to fix various different problems on. And you know, back years ago, I remember when I first started working on vehicles, it was like 5 or 6 years before I ever even saw a wiring schematic. When I finally first saw a wiring schematic, I thought, wow, this is great. You know, it was when I went to work at the Volkswagen dealer that I started seeing wiring schematics, and I was thinking, you know, if I know how this thing's wired up, I can figure out what's wrong with it typically. Well, schematics and connectors, to start with, it's very useful to know how the harnesses are routed. And you're basically, you know, of course, knowing how it's wired makes a lot of difference, but knowing how to isolate the parts of a circuit is just as important. And I understand connector pinouts are a big part of it, but this is from a Nissan right here, and you notice this is basically telling you, giving you an idea of where to go to look to find the harnesses. You know there's a harness running down this way and coming back to the back and all that, and they tell you even here. Nissan's pretty good at this. If you look, some of their, like if you look at the dash wiring, this is just basically overview of the body wiring and the engine control. But anyway, if you look at some of them, they'll give you this specific connector number and all. I'm talking about some of the Nissan ones and all, and I should have put you one of those up there. But anyway, this is what's important, is knowing where the harness goes, how it travels. Like sometimes you may see a connection here and you don't know which way it's coming from or how it gets there. I've run into that on some cars I was working on before, particularly some of the new ones. And you zero in on a problem. This was on my pickup truck. I went out there one morning, it wouldn't start, wouldn't even spin over. And so, and it's an '07 model, so I checked some of the voltages at the sensors, and I noticed they were like, instead of being 5 volts or less, they were like up around 9 or 10 volts. I said, well, that's a ground problem. And so I started digging, and G103, it turned out the layout was right here in the manual. And when I went there, see, I went to this same spot, and I found that rats had chewed the wire off. And that's how I tracked that down. I found that pretty quick. Fortunately, it was pretty easy to get to, too. I had to pull the battery out to get to it. But the long and the short of it is, see, the battery's right here. I was able to pretty much go right to it because I knew that I was, well, I'm going to check this main ground and find out where that main ground is, and then I'm going to go over here and investigate it. And when I got my eyes on it, I saw the problem, and it was very plain. There was another one was chewed into over here too. But, all right, now once you have a schematic, you're a lot closer to a fix. You know, these GM schematic doesn't look exactly like a Ford schematic. The Dodge schematic, the newer Ford schematics look different. Dodge, Toyota, see how they all look different? But then the symbols are a little bit different, but you can figure them out once you get used to looking at schematics. And some of them look surprisingly interesting. Mazda is different from everybody else. Honda looks kind of like a Ford, you know, and so there's your Kia. It looks kind of like Ford. Subaru has got their own way of doing stuff. Hyundai they do as well. And nowadays you got interactive schematics where you touch this wire and it highlights it all the way from where it is to where it's going and all that kind of thing. Even some of your aftermarket OEMs will have that, you know. So this 2005 Cobalt was a no start when it came in. It had been sitting in either a garage or a barn or something for years, and it had originally been dolled up and painted up for Street Trends magazine. And they had taken the fancy wheels off of it and put some plain old steel wheels on it. And the girl bought it with 48,000 miles on it for $1,000. And this was several years ago, so the car wasn't that old at the time, but it just wouldn't start, wouldn't spin over, wouldn't do anything. You know, so anyway, so I says, let's just go ahead and start out here and see what we can see. Because when you turned on the key, you did see some activity on the dash and all that, you know, when you had good battery power hooked up. So there wasn't any fuel pump operation. We needed to see if the fuel pump would even try to run. So we find the fuel pump relay in the power distribution center. And so I like to pull it out. And, you know, of course, I've told you about how I like to hook a test lap between hot and the terminal, in the relay terminal that goes out to the pump, see if it lights up. And this particular one, we found out the relay was installed wrong. The way this thing was configured, you could stick this relay in beside where it was supposed to be and it would go right in there. But two of these places, one of these places right here, they didn't have any wires or terminals or nothing in them. Or, I mean, of course, if they got terminals, they'll have wires. But what happened was that all we had to do to get the fuel pump to work right was pick this relay up and move it over and plug it in the right way, which was pretty interesting that GM would even make that thing that way so that somebody could plug that in wrong. Somebody had obviously been tinkering with it, trying to start it, and they unplugged the relay and didn't pay any attention to how they plugged it back in. It went right in there, so it seemed like it was okay. Well, the network was down when we connected the scan tool. We have no communication. Network diagnostics and a deeper search would come next, but other jobs sidetracked the Cobalt. We'll get back to the Cobalt in a minute. Well, they had this Crown Victoria, had a flashing code 33 with a key on, is the basically the airbag light. And so that's how it came in there. It was flashing that code. And so that points to a driver's side pretensioner. The pretensioner is built into the inertial reel part of the seat belt that you reel out. And what it does is it basically locks that thing when you have an accident. Ironically enough, the airbag pops out, but this thing also locks it so you don't ever touch the airbag. And so, of course, that's destroyed and has to be replaced after a crash. But a passenger side failure would flash a 34. Well, we went in and did a scan tool thing, and it tossed us a B2292, which can point either to the driver or passenger pretensioners. Well, that's interesting. Usually, the lamp flash out code is not as accurate as this code, but in this case, it could have been either side. See, it says restraint system safety belt pretensioner status. Now, this right here is the yellow connector. Your airbag connectors are typically yellow because they don't want you accidentally lighting off an airbag, so they want you to say, look, yellow means it's an airbag deal. Of course, this right here is not particularly dangerous as far as, if you lit this off, you're just going to hear a pop and then this is going to be ruined. But this is what was pointing to. Now, the 33 code told me it was the driver's side. This code just told me there was a problem, so I knew which side to go to by virtue of the flash out code. Now, I did the cardinal sin of measuring ohms. What I did was I disconnected the restraint control module. Look at the pin out here. I got the pin out, this big connector over here. I disconnected it because I found out that it was that connector that went through this driver safety belt retractor pretensioner. And I went to pins 17 and 18. Those were the two pins I found. I made sure I counted down to them right. Sometimes they'll be numbered. Now, this is the connector that plugged into this. I didn't check it here because there wouldn't be any point in it. I checked it, I disconnected the connector, and this is looking into the connector. And that's typically how these things are going to be drawn. So whenever I checked here, I should have seen 2 ohms, for future reference. And you don't need to go using your meter to measure airbag resistance because the meter sends a little bit of current in there to measure. It's probably not enough current to light it off. You don't want that thing blowing up in your face because if you did, it could take your head clean off. But this one wasn't particularly dangerous. Now let's play out this. If I hook my meter to these two and the meter shot current all the way through this pretensioner, all it would do is I'd hear a noise, boom, and then that thing would be no good. So there's no danger there, see? But if you're trying to measure what you're supposed to do when you're working on airbags, they have a dummy load. It's a little resistor you can actually get a 2 ohm resistor and put in, unplug the airbag, put that 2 ohm resistor in there, and then do your diagnostics. Like for example, if you unplug the airbag and you put the 2 ohm resistor in the harness that plugged into the airbag and your code goes away, the airbag's open. That's typically how you're supposed to do that. That's that dummy load thing. And that's a smart way to do that so that you're not putting yourself in any danger. Now, don't measure ohms. I measured ohms on this one before I lit it off because there wasn't any danger. Watch it blow up. 2 ohms is about what it's supposed to have. I got 2 ohms, then I applied power and it jumped. Those things right there, I've got several videos of this. That was pretty. Look at all the smoke. Can you imagine having to try to breathe if that thing lights off in the car? I never really understood why they wanted to smoke everything up like that. I got another one you've probably seen where I lit an airbag off in the passenger side of a Lexus, and it went all the way back to the seat and busted the windshield. I mean, that's how big that airbag was. Of course, it deflates as soon as it lights off, but that thing punching you in the face is like a boxing glove. This one guy that I was hearing about had decided he was going to replace his ignition lock cylinder or something on his little Chevrolet, whatever it was. One of the Chevy mechanics told me about this from the dealership. And whenever the guy took it all apart, when he put the steering wheel and all that nonsense back together, he managed to pinch one of the wires going to the airbag. And you know, the airbag basically it's not hardwired to ground or power. It's going to get both of those from the module when it gets ready to light off. And so this guy had pinched one of the wires to ground, and when you turn on the key, it sends juice up through that airbag squib and it looks for it to come back on the other side in the module, so it'll know if the bag is, you know, or the clock spring's open or whatever. Well, this guy was, you know, leaning down in the seat, and he switched on the key and it deployed the airbag. And he had a big raspberry on the side of his face where it knocked him back against the seat. And he had to buy an airbag that cost $600 or $700 to replace the one he had deployed and then try to figure out what. I mean, this was a mess. You know what I mean? So if you don't know anything about this stuff, it's best just let somebody else work on it. Now the pretensioner was replaced. We put a pretensioner on it, and that took care of the code. You know, that was really simple. But the point was, I went to the pinout to do my diagnostics to make sure. Now, what I also did that I didn't talk about here was I disconnected the this yellow connector. When you disconnect the yellow connector, there's a shorting bar built into the connector that touches both of those pins, right? Okay, and so that keeps, well, I'm going to say that a shorting bar in here. So I was thinking, you know, if there had been a shorting bar in this other connector, I wouldn't have had to jumper it. But what I did was so the unit's got a shorting bar, the connector that unplugs does not. But I actually bypassed, I just used a piece of wire on this one, I bypassed that circuit, and then I rechecked it 17 and 18, and it was a dead short. So I knew that it wasn't a wiring problem between the module and the pretensioner. That way I knew it was a pretensioner. So $100 later I had a new pretensioner on there, and it was fixed. Well, back to the Cobalt. The gas smelled fine in spite of everything. I guess that it was dry and they had put some new gas in it or something. With the relay in place, we had good fuel pump operation and pressure. The engine controller knew how to turn on the fuel pump, so it was awake, turned on the key, and the engine started. Believe it or not, that was a real surprise. But we had an intermittent gremlin. Periodically, this security light would come on while the engine was running, and then you'd sit here and say, wait a minute, the security light's on and the engine's running. Well, when that came on, it was a network issue is what was going on. Switched the thing off, turned it back on, the engine's still running. You couldn't even switch the engine off when the security light was on with the engine, if the engine was already running. Of course, if it wasn't running, you couldn't start it. It wouldn't even spin the starter. So I'm saying, well, here we got to figure out what's going on with that. You know, we also had an issue with the transmission control module. Well, now I wondered if maybe the time in the barn caused issues that would go away. And once electrons flowed through the PCM brain for a while, you know, that's the best spin I could put on a dicey situation like that. I didn't really believe it. But to my surprise, the longer the thing ran, the more stable it became, to the point to where it didn't give this problem anymore. We didn't do anything to fix it. It just more or less, you know, limbered itself up electrically. That sounds totally insane. Let me tell you another little story about something laying there not being used. I bought a brand spanking new Chicago pneumatic air wrench, impact wrench, half-inch impact wrench. Paid $99 for it. Not long after I retired, or it may have been before I retired, I don't know. It was a long time ago that I bought that doggone thing. Put it in my toolbox. I mean, if I used it to take the lawnmower blades off, because you know how annoying they can be under this 48-inch deck. And my previous impact wrench was just old and wore out and all. I said, I'm not going to have this. I'm going to buy me this brand new Chicago pneumatic impact wrench. And this is a good one now. And I put it in my toolbox for a long, long, long time. And I'm talking about, heck, I don't remember when I bought this thing, but it's got to be 16, 17 years ago. And so I took it out when I was working on my Explorer, putting those knuckles on there or something. I did a video on that. And of course I've got this 20 volt DeWalt now that I use, you know, and I carry it around with me in case I have a flat. But this crazy thing, my goodness, that good air pressure going to that Chicago pneumatic wrench. I put it on there and it felt like a half-baked junk impact wrench that was worn completely out. It wouldn't even break a bolt loose. And it had just been laying in my toolbox in a climate, you know, not climate friendly thing. It wasn't wet or watery or nothing like that. But that thing laid there long enough where I'm going to have to take it apart and clean it up and rebuild it, I guess, to get this stupid thing to work right again. And it had been used like 3 times and it laid in my box. So you'd never think an air wrench would do that. Just like you'd never think a computer system would get to where it was all whacked out like this one and doing this crazy stuff that it was doing. But it sat up for a long time. Well, the electric power steering was dead in the water, and there was a mess. That might have been why they stopped driving it and parked it in the barn. I don't know. But as for the transmission control unit, the transmission wouldn't shift gears, and the speedometer was flatlined. You didn't have any kind of speedometer operation. So here we had this, you know, of course, that power steering message there and all that. Well, I said, let's look at the transmission control module issue first. So with strong battery voltage, good ground at the TCM connector, we condemned the TCM. What it did was, see, we found out which pins had power and ground to it. See, and you go to this pinout, you got to count off, you know, because this thing is basically telling you they got 1 and 12 and 37 and 48. So you basically got, and there's 49. That's the big one is the ground. You notice that? That's this one right here. And so we checked for a ground there, and we checked for power, you know, at 31 and 32. And we had to find those pins. And once you find those pins, and you better make darn sure you're on the right pins, or you'll misdiagnose. And if you ever have to take connectors out of those cavities, don't put it back in the wrong one either. And so we had the speed sensor here on 41 and 16. Had a good signal there. You know, as far as, well, I say a signal, we had good resistance there. And if you spun the wheel, you could tell that it was putting out some. So I said, all right, this is basically going to look to me like a TCM issue. And so we replaced the TCM, got one from LKQ, believe it or not, for $100. And that was, we got the data stream, speedo operation, and transmission shifts after that. Everything came back online as far as that kind of thing goes. Now this other problem I was talking about that went away by itself, went away before we ever replaced this. So the TCM wasn't causing the network issue that was causing the security stuff and all that. But that's an interesting little module. It's not big as anything. It's about the size of your hand. And it was, you know, got some serious solid. See how skinny it is? And it slides right down in here on that thing. Real easy to get to. All right, the power steering message was handled under a GM recall. I found out that there was a recall replacing it. We had to replace one of these on a Pontiac G6, I think it was. It was out of warranty, and it was like $500 or $600 for that doggone thing. But this one here is not like, it's not on the steering gear. It's got the this thing helps you turn the wheel using this this motor here, and it's basically those power steering motors are all brushless motors because they can instantly, you know, apply power. You couldn't have a brushed motor for something like power steering that needs to have maximum power but without a whole lot of speed, you know what I'm saying? So that's why. Anyway, this is mounted right under the steering column, and it was had to be replaced by GM. After that, now they had done some engine mods and stuff too, and the girl didn't drive it all that long because she said it got such horrible fuel economy. So I think she sold it to somebody else. But anyway, we've been here about 20 minutes, but knowing how to track a circuit using wiring schematics, harness routings, connector locations, and everything, and learn how to use those pinouts. You got to dig where they are. You got to find them. You have to get online, do the stuff that you have to do. But finding those pinouts is all the rave, and that's what I've been doing for 40 years. I learned how to do that kind of early on. That's how you fix stuff when you're doing electrical stuff. Well, I'll see you guys next week. This is kind of in tandem with that previous video I released. It was just, you know, a slideshow going through there showing you how to track down stuff. I hope these together will be pretty useful to you. But I'll see you guys next time.